Hello everyone. In this problem, there is a cubic function f of x, and the leading coefficient is positive. And g of x consists of two parts. When x is less than t, g of x is minus f of x. And when x is greater than or equal to t, g of x is f of x. And because g of x is continuous, f of x should be reflected at the x-intercept. And from the first condition, g of x over x times x minus 2, there is a limit value. So that means g of x contains x and x minus 2 as a factor. So f of x will also have x and x minus 2 as a factor. And because f of x is cubic function, we need to have one more factor. And because we don't know about the factor, let's say the factor is x minus alpha, and the leading coefficient is a. So let's think of the graph of f of x. Because x-intercept of f of x is 0, 2, and alpha, f of x will go up and down following this x-intercept. And there are three cases for the graph of g of x. The first case is when t is alpha, the graph will be reflected at the point of alpha to make the graph of g of x. The second case is when t is 2, the left portion of the graph will be reflected across x-axis at the point 2 to make g of x. And the third case is when t is 0, the graph will be reflected at the point when x is 0. And when the limit value g of x over x times x minus 2 is negative, when x goes to m is natural number, and there are two such natural numbers. One is g of minus 1, and the other is minus 7 over 2 times g of 1. And when we think of the sign, because these two values are natural number, that means both should be positive. So that means this g of minus 1 should be positive number, greater than 0. And in this case, if we only look at the sign of g of 1, because of this negative sign, to make the whole term positive, g of 1 should be less than 0. So from this graph, when you think of the sign of g of minus 1 and g of 1, in the third case, in this case, g of 1 should be positive number according to the graph, because that's against this condition. That means we can eliminate the third case. So that means t is either alpha or number 2. And let's say g of x over x times x minus 2 is the due function h of x. So when we think of the h of x, it also consists of two parts. After factoring x and x minus 2 out, when x is less than t, h of x will be minus a times x minus alpha. And when x is greater than or equal to t, h of x will be just a times x minus alpha. So let's think of the graph of h of x when t is alpha. In this case, the graph will be reflected at the point of alpha. And in this graph, there is no negative part. So that means we cannot make the limit value negative. And that's not the case we want. So we can also eliminate the case when t is alpha. So when t is 2, when you think of the graph of h of x, the graph will be dissociated at the point number 2. And in this case, there will be two natural number which make the limit value negative. One number is 2 and the other number is 3 according to the graph. So that means these two values are 2 and 3, but we don't know which one is 2 and which one is 3. So let's try to find the value of g of negative 1. Because negative 1 is less than 2, we need to use negative f of minus 1. So in this function, put negative 1 in place of x, keeping this negative sign, and that makes 3a times 1 plus alpha. And to find the value of g of 1, because 1 is also less than number 2, we need to use negative f of 1. And that will make a times 1 minus alpha. So negative 7 over 2 times g of 1 is equal to 7 over 2a times alpha minus 1. And to decide which one is 2 and which one is 3, let's make an educated guess. Because alpha plus 1 is greater than alpha minus 1, we can reasonably think that the term containing alpha plus 1 will be bigger than the term with alpha minus 1. So I'm going to think that the first part is 3 bigger number and the second part is 2 lesser number. So with the assumption, the value of a is 1 over 1 plus alpha, and from the second equation, the value of a is 4 over 7 times alpha minus 1. And make the cross product. So if we solve this equation, the value of alpha is 11 over 3. And from this graph, alpha should be greater than 3. So that goes well with this value. And when alpha is 11 over 3, the value of a is 3 over 14. And that's also there also matches the condition when the leading coefficient is positive. And finally, we want to find the value of g of minus 5. Once again, because minus 5 is less than 2, we need to use minus f of negative 5. So put -5 in place of x, and then use the value we find for a and alpha, and the product of 5 and 13 is 65, so that's the value of g of -5. So the answer for the problem is the answer for the problem is 65. So that's it for this video, and thanks for watching.